Welcome to Coach Eichner's Math. Today we'll be talking about triangle inequalities. My suggestion to you before you watch this video is to pause it, grab some toothpicks, some straws, some pencils of the same length, anything of that sort, and take one of those items per side length, okay, whether it's 2, 2, and 2, or 2, 2, and 3, or 2, 3, and 4, and see if you can form a triangle. Remember that there must be no gaps, and my segments must make lines. My pieces must make lines with no bends in them. Go ahead and see if you can do that. See how many of these different sides make triangles. Welcome back. Hopefully you took time to do that. Right here is our chart that we got to. And what's important here is looking at it as an investigation. We were looking to see which pieces of this chart stand out from the rest. So what I'm doing right now is I'm looking for anything that does not make a triangle, that I could not make a triangle out of. So as I'm looking through, there are 3 of them that stand out to me. And I'm going to go ahead and let you know that the important column that we're looking at here is this column right here. Notice right here in this column, 4 would be greater than 2. The sum of the short sides is greater than 2. Here, when it is not a triangle, the sum of the short sides is equal to the larger side. And down below, the sum of the short sides is less than the sum of the larger side, which should make sense to you. If you think about it like this, we're at school right now. You've got 7-Eleven on your way home, and you are trying to get home. There is no way, if you're walking, that you can take fewer steps going to 7-Eleven and then to your house. And unless you live at 7-Eleven, going to 7-Eleven and then your house should give you more steps than just going home. If at any point my two-sided trip is shorter than my straight trip, the shortest distance, we've got an issue. It cannot form a closed polygon, which means it cannot be a triangle. So, thinking through it like that, this leads us to the thought process that in order for a triangle to be greater, or in order for a triangle to be constructed, the sum of the smaller sides must be greater than the larger sides. So, looking down below, it says determine the following sides will make triangles. If yes, then classify. So, real quick, that brings me back to a point here. 3 of these, we classified them, but they were not triangles. So I cannot classify them as triangles. Go ahead and put a line through those 3 as they cannot be classified since they are not a polygon. Looking down below, I'm going to go ahead and help myself. I'm going to go ahead and highlight the largest side so that I know which one's larger. If all 3 are the same, I'm just going to pick one. Doesn't matter. So right now as I'm looking at it, 8 and 9 would give me 17, which is greater than 10. So yes, this would be a triangle. And in this case, it would be a scaling triangle. 1 and 1 add up to 2. 2 equals 2, so no, this would not be a triangle. 6 and 6 give me 12. 12 is greater than 10, so yes, this would be a triangle. It would be an isosceles triangle. 3 and 5 give me 8. 8 is greater than 7, so yes, this would be a triangle. It would be a scaling triangle. 4, 4, and 4. 4 and 4 give me 8. 8 is larger than 4, so yes, it would be a triangle. In this case, it would be an equilateral triangle. So, real quick way to check and see if you have a plausible triangle in front of you. Look at example 6. The sides of a triangle, 3 and 7. What range of numbers could be possible lengths of the third side? Well, there's 2 options. We can say that 3 and 7 are the short sides, Or we could say that 7 is the longest side. So as we're going through it, let's look at 3 and 7 being the short sides. If 3 and 7 are the short sides, 3 plus 7 gives me 10. So I know that my number for my long side must be greater than 10. So I would say here that my third side, we'll call it x, must be greater than 10. If we claim 7 is the long side, we'll use x again. We'll say 3 plus x has to be greater, has to be greater than 7. Let's go back and look at the first one real quick. If 3 and 7 are 10, those are my short sides. My short sides must be greater. So let me go ahead and flip my sign here and say that x must be less than 10. X must be less than 10 because my two short sides are 10. So looking over here, my two short sides must be greater than the longest side. So 3 plus x is greater than 7. Well, if I subtract 3 from both sides, x must be greater than 4. So in this case, to sum it up or to put it all together, I'm going to say that x is in the middle, and x must be larger than a number, and it must be smaller than a number. So, x could be any number greater than 4, and x could be any number less than 10. And this is considered a range of numbers. 4 is the smallest number that would not work. Now if I did 4.1, it would. 10 is the largest or smallest number that would not work. If I did 9.9, it would work. So any number between 4 and 10 on a number line would be possible solutions for this triangle. Flip it over. Go ahead and try this next one on your own, and then we will talk about it. All right, so my two options, 9 and 20 are my short sides, so 9 plus 20 must be larger than x. Or 20 is my longest side, so 9 plus x would have to be greater than 20. So, to get this done, we're going to say that 29 must be greater than x, or I'd say that x has to be greater than 11. So I'd write it down to put it all together. And the way I always do this is I always write it the same way. I say x, some number is less than x, and x is less than something else. So in this case, x would have to be less than 29, and x would be greater than 11, or 11 would be less than 29, which is less than x. So, right there would be your answer. Way to see that on a number line. If I go ahead and draw a number line, I say 11 is here. We'll go ahead and say 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way to 29. Any number in there, you could say 12 or 13 or 15 or 19 or 15.2 would all be possible solutions for the third side. It would not include 11. So as I draw this picture, for those of you that are visual, not include 11, not include 29, which means they're open segments. Excuse me, but it would include everything in between. So let's look down at the next piece of our puzzle. In a triangle, the largest side is opposite the largest angle, and the smallest side is opposite the smallest angle. So right now, angle A is 120, angle B is 40, and angle C is 20. So the largest side would be across from the largest angle. My largest side would be segment BC. The smallest side would be across from my smallest angle, which would be segment BA. So looking down below, we can classify the triangle, then list the angles from smallest to largest. So when I classify, I'm going to classify by sides. I know I have 9, 12, and 15, so that must be a scalene triangle. And I'm going to talk about my angles based on their size. Well, just like we talked about before, if we look back up above, it says the largest side is opposite the largest angle. Well, largest side is 15. Largest angle must be A. So, from small to large means that angle A would be my last angle. Similarly, my smallest side is across from my smallest angle. So my smallest angle would be angle B. And to finish up, the one that's left over, the one that would go in the middle, would be my middle side length, which is C for an angle. Angle C would match up with the side length of 12. So, last example here on today's work. List the sides of triangle ABC in order from longest to shortest if the angles are what has been indicated below. So this takes us back to the fact that we know we have three angles. Measure of angle A and the measure of angle B and the measure of angle C. And the best part about it is because it's a triangle, they add up to 180 degrees. So for our purposes, we're going to say 10x plus 5x minus 17 plus 7x minus 1 equals 180. Or 22x minus 18 equals 180. Or 22x equals 198. And then we need to divide by 22. And dividing by 22 right here, you should be able to find that x is 9. So, not done yet. I now know that I'm going to go ahead and plug them in. I'm going to say the measure of angle A is 9 times 10, which is 90 degrees. The measure of angle B is 9 times 5, which is 45, minus 17, which is 28 degrees. And the measure of angle C is 9 times 7, which is 63, minus 1, which would make it 62 degrees. So I'm going to go ahead and draw us a picture. Talk about angles A, B, and C. It doesn't really matter to me which one's which. They say this is 90. They say this is 28, and this is 62. Now I know it's not drawn to scale, but what they asked me to do is they asked me to list the sides from longest to shortest. So, just like up above, longest side goes with the biggest angle. Biggest angle is 90, so my longest side would have to be BC. So I'd say the longest side, segment BC. Second longest side would be the second longest angle, or second largest angle, which is 62. So I would say that my second longest side would be segment BA. And my shortest side will be across from my smallest angle. So in this case, my smallest side would be segment AC. And that right there would be the answer to my question when it asked me to list my segments from longest to shortest. Again, this is Coach Eigner Math. I appreciate your time. Hope you have a good rest of your day.